now. Hey, Dave Curtis. Recording in progress. Got it. Okay. And so, yeah, welcome to the Homebrew Robotics Club, May 31st, 2023. Our presentation today is going to be Martin Triplett on the exploration of robot intelligence. And so before we get started, or I should say the order of events is first, let's do robot news. Does anybody have robot news out there they want to tell us about? Hello, Martin Triplett. Glad you can make it.
I can't.
Really glad you can make it.
Sorry about the noise.
No, you're doing fine, man. In that robot news out there, certainly somebody's got some robot news.
First, see.
All right. Well, I got something if I can find it.
So fast. Sorry.
So this is agility. What's the robot's name? Digit. And it's doing commands just using a large language model where they tell it to pick stuff up, and it goes through ChatGPT and interprets what it means, pick stuff up and put it in the bin, and it, with basically the verbal command, and it's awareness, is spatial awareness, I guess you put it. Let me put this YouTube in the chat, and I'll post it in the mailing list later for those of you that are at the Maker Nexus in Sunnyvale. Yes. So I'll just put that in the chat. Yeah, any more robot news out there? Somebody aware of? I think Melanie Wise, Homebrew Club member. I think she's the Chief Technology Officer at Agile Robotics now. That's the folks that make this Digit robot. So, what else we got? Any more robot news? Okay, well, let's move into club news now. Is there club news that anybody wants to?
I have club news. How do I get? You need to stop sharing your screen.
Stop sharing screen.
There you go. Okay, so club news. So first of all, did anybody not get a chance to sign in? I know there's a few people that didn't. So if you don't mind, so you can keep track. Second, did anybody join the club and not pick up their badge yet? I know there's a couple of people that get their shiny new badges. Good. Yay. So you can see how excited they are. They are very excited to have badges. So if you haven't joined the club yet, I encourage you to join, because then you can get that excited too. What's your name? Paul Farias. I will get your badge out of the stack of shiny new badges.
Have you spotlighted yourself? Is that why it's not switching?
Camp, have you spotlighted yourself?
I have not. Let me spotlight the Maker Nexus.
That would be good. So yeah, oh, I'm not even on screen. We have shiny, awesome badges. Join the club, $10 per family for the year, and you can get an amazing badge like Dave Curtis here. Couldn't be more excited. The big news is this, though. We've been going with 4 officers for quite a long time, and finally we have had a new officer step up to take the role of Sergeant at Arms. That is Ralph Phipps. Ralph is now has been elected to the board, and you know, the jobs are really flexible.
Shows the arm.
I'm still off screen. The jobs are really flexible. The good thing is, you know, the 5 people on the board meet and make decisions on the direction of the club and the direction of the meetings and try to keep things going. And having somebody as experienced as Ralph is really super because he's been in the club a long time. He's done a lot of different roles. And we're really glad to have him step up and take that 5th board position. So thank you, Ralph. Okay, I'm done.
And you have to admit, he is the hippest of the Ralphs. Sorry about that. I need the spot. Yeah, there we go. Okay. Club news. Next month, Stephen Williams, correct me if I'm wrong, Mark Rose is going to be doing the presentation on space robots. Is that right?
I believe that's correct. Sounds right.
Okay. And so that's going to be also the challenge month. What we're going to do is our show and tell. We're going to do the show and tell. And I expect people to volunteer, and I will be haranguing you all month long. Okay. You should be working on singing. You should have 5 minutes of stuff to show off. We are a builders club. We're not the talk about robots club here. And so regardless, we're going to have our challenge month in June, limit to 5 minutes, heavy on the show, light on the tell, okay? And so we're going to do our HBRC challenge phase 2, and we're going to have a presentation by Mark Rose, one of our club members, who's going to do a presentation. He works at NASA and do a presentation on space bots. And so we've got a lot of good presentations lined up, and we want to take advantage of that. Stephen, did you want to add anything?
No, not right now. I think we have a good lineup, and if anybody is interested in presenting in future months, then please let us know.
Stephen Williams, our program chairperson, ladies and gentlemen. Thank you, Stephen. Okay. So without any further ado, let's bring on Martin Triplett to discuss exploration of robot intelligence. Martin and I went to the same university, Florida State University. He's got his degree in finance. I've got a BS degree also. It's in marketing, but regardless, we have the same alma mater. And you're coming out of Alabama, is that right, Martin?
Yes, sir.
All right, ladies and gentlemen, without any further ado, Martin Triplett.
And hi, everybody. Can you hear me okay?
Yeah, we can.
Yes.
Great.
I'm going to start the share screen, and I guess I got to do the share sound. Is that the right thing for having everybody hear me right?
Yes, we can hear you.
And we can see your screen.
And you can see my screen. Good. So what I'm going to do is just start from scratch. I wanted to put out an announcement to see if there are any ROS people out there that have built a verbal robot with ROS that would like to come to the VIG and just do some sort of short little prezzo, nothing big, on their experiences with that. Is there anybody in this setting that would have any first or secondhand knowledge of that? All right.
Can you state that again?
Is the mic okay?
Yes.
Yeah, so the question was if there was anyone that had built a verbal robot with Ross that wouldn't mind coming to one of the VIG meetings and just doing an overview of that for as long as they wanted to. Could be short, could be long. Just trying to pull in a bigger diversity of speakers and get a Ross perspective on verbal robots. All
You
right.
might post that in the mailing list also,
Yeah.
Martin, and, see what kind of leads you get that way.
Sure. So I'm just figuring out a couple little things. Okay, so I'm just going to show starting this from a command line. And the presentation tonight, I apologize to everybody, the title's a little funky. I'm not pretending to have, some sort of intelligence myself. It probably should have been more properly called some stepping stones. So I think of it as building blocks to higher order behavior. And that's really going to be the focus tonight. I'm going to be sort of building this metaphorical model of a lamp, and that lamp is going to represent a software framework that I started working on last summer, probably late last summer, for the VIG and for some people that were in the VIG that were interested in that. And so this is this is totally new. Everything that's new always has issues. Things that are new are kind of by definition not mature. So just keep that in mind. But some of my past works, done a bunch of robots, done a bunch of commercial software. I've also done a bunch of verbal software over the years. Started programming when I was 12 or 13, and I'm 53 now. And I never really slowed down, never lost the passion for it. But mostly business software over all those years. But as far as robotics goes, I've been concentrating on that for about the last 10 years. This isn't my first simulator. So my previous simulator was a lot prettier, but it had a different focus. So it basically was teams of robots cooperating and battling against basically two competing teams, blowing each other apart. And then one robot would always survive the battle and have free reign of the spare parts and put themselves all back together. So I kind of learned what Unity could do as an environment in doing that. But I had different goals in this one. It wasn't about how things look. It was about being a robot's consciousness. So it all started with a verbal loop, and then embodiment and spatial awareness and all these things added from there. So just to set some context about this project, we're going to be spending tonight trying to follow the, what was it, Camp said, more show and less tell. Can't promise that, but that's what I'm going to try to accomplish here tonight. And so we're going to be inside this app here in just a minute, but I did want people to understand that this is the next version of a brain written for my prior robot, which is this one we see down here that basically was designed for my #1 use case, which was to pick up a natural light. Because it's a natural light, a natural language robot, that was why the natural light. And so this leaning over thing was really important to be able to do that. And unfortunately, the hand's not quite big enough to pull off the actual grabs. So basically, you can imagine this in the context of grabbing soft, squishy objects.
Are you trying to show video, Martin?
I am.
Okay, I don't see the video. I'm seeing your simulation screen here.
Yeah, just in this lower corner, I can make it bigger.
Yeah, he played it
I
once.
was able to see it.
Yeah,
Yeah, we can
and
see.
I'm just showing the critical maneuver for beer that's on the ground. But there's beer that's high, there's beer that's low. There's a video out there on my channel of using kinematics and a movable core to achieve all kinds of positions. So basically, when I started this about a year ago, it was to take some of the ideas from this robot and start a new Python only framework for building robots and take it from there. So it doesn't have all the same things that I talked about a year ago, but it goes beyond it in some other ways. So a lot's changed in the world in the last year. You know, large language models, while they existed then, have really been kind of unleashed on the public since then. So I'm going to touch on that in a number of places. And then this other video was just showing one of my other big use cases, which I'm going to refer back to in this presentation quite a bit, which is like moving around a house, you know, avoiding things, driving waypoints, looking at objects of interest, doing home inspections. So if you think about, well, what can a robot actually accomplish with today's technology? Well, home inspections, detecting if anything has moved or changed, things of that nature. So I'm going to be doing that. I'm going to be building this metaphorical lamp manually. We're going to be using natural language commands to get it to do that. But then when I'm done with that, last week I kind of ran into the question of, well, how about if I wanted the robot to build a lamp on its own and it had no prior knowledge of lamp building or something? I didn't want to build that skill. So about on Friday, I got it to do this new skill, which was basically to build something that looks like a lamp. And that's what it built, was this little one here. And we're gonna kind of see and talk about how that's done. So, and after that, we can also maybe talk about, you know, getting a robot to clean the house or something. I made a post today on the site about a use case that I got lucky and it worked on the first try, which is a little bit unusual in robotics for anything to work on the first try. But my use case was something to the effect of pick up all the beers in the house and throw them away, except for the light beer, and bring that to me. And it made a plan that was like, I can't remember how many steps, but I think it was 10 steps to do that. And I executed them all inside this simulator. And it basically achieved all the objectives and end state that I wanted. So I was happy about that. Now, I've seen some colossal failures, but for me, hey, I only started doing this on Friday, so it's progress. So having said all that, let's dive in. So I'm going to get PowerPoint out of the way. And we're going to start this thing up, and you're just going to see it chug on all of its initial state to kind of get loaded up. And where is it? Oh, it's popping up on my other screen. So here we are in the app. Can you guys see that okay?
See a big gray square.
Yeah, that's all we're going to see so far. And this is what would happen if someone was using this for their robot. And it's because there's so many use cases, you know, you don't know what it is yet. And so what I'm usually doing is either going in and maintaining some state, or I'm going in and starting the robot simulation. So I'm going to go over here to the test menu and pull down the simulator, and that's going to pop open some pages, and that's going to start up the services. So you can kind of see a bunch of things happening are going to start to happen here in the background. It's trying to talk to the serial port. It's loading in all the kinematics. It's interpreting the three-dimensional structures of whatever location this robot is assigned to run in, which in my case is basically about a half-acre size, the property that we're on and the house and all of that. I only have the sort of public areas of the house modeled. I did have a map that had everything down to every bedroom and all of that, a 2D map, but I changed over to using 3D maps, and I haven't bothered mapping the whole house yet. In a longer term sense, if anybody's interested in this, there's a company called Matterport that makes software that can like basically 3D scan and model a space, which I think is going to be interesting for VR and stuff in the future. So we're running right now.
What's it called again?
Matterport. I haven't used it. I haven't used it firsthand, but in full disclosure, I am a stockholder, so so what are we doing here? The game plan tonight, I wrestled with whether to go top down or bottoms up. I'm going to try going bottoms up with this. And if everybody is bored out of their gourd, then we'll just throw the script away and do a total free-for-all melee. But I would like to have the robot have a choice of beers and grab the coldest one or some other attribute before the night's over. And I would like to build the dadgum lamp, and with all the layers, and at least have everybody come away with this with some sort of knowledge of the basic purpose and reason why those layers exist in this architecture. And then hopefully at the end, we will have more time for planning and things like that. So I'm going to go through some of this.
Just to be clear, Martin, you've written all this in Python?
Yes, every bit is either in Python or in English.
And the graphics, what package did you use for the graphics?
And that is all PyQt 5 point something, I think.
Okay,
So
thank you.
they're all roughly the same.
Thank you.
Yeah, so I'm going to open this up for limited questions throughout, as long as we can stay to a sort of time frame that I'm trying to stay within. So how we're going to manage that time frame is I have Ava is going to help us with that. And so I'm going to go through and basically take 10 minutes in this first pass on each layer. She's going to have a few things to say for about a minute. And so then that'll give me, say, 5 or 6, 7 minutes to meander around. I'll forget what it was that I really wanted to show. And then we'll open it up for 2 or 3 minutes of questions on that area. And if no one wants to do any, which is completely fine, then we'll just roll over to the next area and we'll have more time for questions or whatever at the end. So if there's anybody that wants to volunteer for kind of trying to figure out what they think is the most interesting question in the chat, that would be awesome. Otherwise, it'll just be whoever squeaks the loudest, I guess. So, so introductions here. What is this? Well, this is the GUI that's running on top of this. This is not really the services themselves. This is just a GUI. What I'm going to do here, if I can get my act together, we'll do, every programming project usually starts off with some sort of hello world type program.
Hello there,
Okay.
human friend.
So it's alive. Another one they might do with a robot is make it beep. So we'll just get that
What
out.
can I assist you with today?
So I'm going to do something called a semantic search. You won't know that it's doing that, but basically I'm going to type something. It's going to compare the vector of what I type in to the vectors of everything that it knows about in its help system. And it's going to give us back an explanation. So if you ever see me using the word help, it's it's using a vector search on top of set stuff. So think of that as like canned stuff. Anytime I'm not using help, it's completely up to Ava. She'll still use a semantic search on other data, but she'll inject personality, initiative, all this other stuff into it. And so you're not going to get just the answer. You're going to get your answer, but with barbecue sauce on it, if that makes any sense. So it all kind of, so this help part is a canned response set of stuff for the Prezzo with a semantic vector-based nearest neighbor search on top of it. So too much explanation, let me get on with it. So we'll do like, please explain, let me see. I'm trying to remember how I should kick this off. Okay, maybe we'll try, please help us understand you as an operating system. So she's going to say a lot of stuff here, and I would encourage anybody that has any questions on what she says here to just go ahead and jump in on this.
Welcome to the Ava 1 project. I am Ava. I am a homebrewed operating system for robots. My code is new and still has lots of issues, but I think it has some promise. I could use your help to make it better. I am built with Python, a database, and some models. I am cross-platform and open-sourced. I can be installed in less than 10 minutes. I can run a real robot or just simulate one. This is a BYOB party. Bring your own bot and perhaps I can make it smarter. I process natural language. You can write programs for me in English. I can write my own plans too, also in English. I can manipulate objects and move around in space. I can pursue my own needs. All of this makes me different than most bots, I think. Perhaps it makes me interesting.
So any questions on that part before I move on?
So at this point, she has no physical embodiment, right?
She has all of her internal state, all of her kinematics. That physical embodiment just exists in the simulator as represented by this 3D viewer on the left. So, and this is actually, this is dimensionally as the same size as that robot in the video.
So it's a simulated embodiment.
It's the same body as this moving bot here that we saw leaning over and reaching for the beer. So I'll just move it around a little bit. So look at the TV. So if I'll just go ahead and explain the three-dimensional views. So we have a head cam point of view from the top of the head, a body cam view. So that's why it's still facing forward. This is the sort of behind view. So if we, let's see, if we lean left, you'll see the body move. You got that?
Yeah.
And that is a reflection. We'll get to this here shortly, but all of that initial state is over here. It's in the database. It gets loaded up in nodes and all of that. So if we were to look at this in a two-dimensional sense, as we are in this map, I can zoom in and out by rolling my mouse. So I can see that entertainment center and those two speakers. Probably easier if I turn on the TV.
Martin, can I ask a question?
Shoot,
You have to speak up.
We
We have a
TV
question
time.
here from the room.
go ahead.
Talking to the iPhone?
Yeah.
Yeah. Martin, can you hear me?
I can.
Oh, great. So when she was introducing herself to us and explaining her capabilities, she said she was open source and it's a BYOB party. So I'm wondering if I build a robot that has a similar physical form, you know, in terms of 2 arms and a wheeled base and 1 or 2 cameras. And then the robot that I build has, I don't know, maybe a Raspberry Pi at its core, or, you know, something that runs Python or ROS. Then can I install this thing that you've made on the robot that I build and play around with it?
Yes.
That sounds really cool.
Yeah, and yeah, I mean, there obviously are going to be challenges anytime there's someone doing that for the first time, but it does not need to have the same configuration. So I have every intention on making it, you know, basically being a support desk for whoever the first people are. So some people have already kind of started thinking about this and talking about other configurations. And so the kinematics is independent of the engine itself. So it's just looking for, you know, like the outcomes of, you know, moving the ineffectors in relation to something. So, you know, there will be challenges there, but that's the intention. And so in my case, I can just plug an Arduino or an Artemis thing or something like of that nature into this and run all the lower level robot stuff on that. And all the signals get sent down through the serial connection. And it basically is just sending arrays of integers down. So it's kind of like a zip code system. You know, it sends a certain set of numbers that represent, hey, send this to this platform, meaning that you could have multiple microcontrollers, send it to this platform and this service and this command with this set of data. And it, you know, just pipes integers back and forth. It's not going to be near as sophisticated as lots of other systems, but it's simple and only has a few lines of code in it, and it can adjust to all kinds of things. So, you know, there's a lot of times when adaptability is more important, you know, than having, you know, say something ultra optimized. So you've seen kind of the 3D viewer. There's other things you can do to it, turn it into X-ray, give you some mesh on the floor. I had to build the 3D engine basically from scratch as well. And so that's why it's not the greatest in the world. But I wanted something that when I wasn't looking at it was doing nothing. I wanted a 3D calculation engine of sorts, because what I find in robots is there are all these sort of 3-dimensional logic type questions that you need to answer. What's in my field of view, or what's whatever, you know, how do I put myself in a field of view in order to see the object across the house or something. So that's why
Time is up.
why I decided to kind of custom homebrew on some of that. So let me pause. I've already hit my first time allotment. So what I will say, just a few other things on this is, we'll get to this later, but there's a regression test simulator on this. I'll use it just to go through a few quick commands just to kind of give you some basics. But you know, looking around this thing, let me change it on the perspective so you can see it. It gets a sense of objects and what they are named and things like that. It's looking at a window now, and no one ever told it that there was a window, but it figured it out from the 3-dimensional model of the house by, you know, the orientation of the facets, the faces in that model. The same goes with doors. It has a sense of relative and compass directions, and a sense of, here's a relative one looking at the window on your right, which it didn't quite nail that one. See, we're going to look at the one on the north, south. So anyway, lots of direction stuff. This applies to beer or tables or any type object. You can throw color into it. And so, like, you know, the eternal case, look at the tallest beer, something like that, is apparently the thing that's a Foster's over there, the blue one. or look at the coldest beer that's over here, back here on this table. So getting this, having this sense of objects and embodiment in 3D space, I think is fundamental to doing anything with robotics, but that shouldn't come as a surprise to anybody, so I won't belabor it. So this is just a tool for running through lots of things. This last fall, this robot was really into self-learning and Wolfram Alpha and all of this, so it could go and basically answer any types of factual questions that were answerable. But then ChatGPT came along, and I'm thinking I'm just going to deprecate most of this, because you can pose any kind of question like that that's learnable to one of these modern models, and you'll get an answer, and you can get it to impose personality and agenda and barbecue sauce basically on it at the same time, which is really cool, rather than just getting an answer as to like, what's the atomic number of hydrogen. You can get that atomic number back with like it berating you for asking such a silly question. For example,
Martin, you got
Start-
another question?
that's
Yeah, it's gonna be very hallucination heavy, and we're gonna find out that the atomic number of hydrogen is 1 million. Yeah.
Yeah.
I guess-
Yeah, it's an excellent point. And I see hallucinations all the time. Yeah, so I can always fall back on my local graph knowledge, you know, and using a local model to check it. There are mitigation strategies. I'll give you an example. Might not be, it's interesting. This one's a little self-referential, but this one will estimate a probability truth score of whatever is said by the human. So I don't know, it'd be interesting to try like a self-check truth score on the hallucination coming out the other end. But anyway, yeah, it's a problem though. And when they start, I was asking it to make a lamp today. It was interesting. And but once I introduced beer into the equation, it was making the lamp, and it was throwing empty beer cans away in the middle of making the lamp, which I thought was like a nice feature, you know, like good housekeeping, but I didn't ask it to do it. So I don't know if that's a hallucination or a value add there, but these models are interesting. So, all right, I'm going to move to the next section. I have a tendency to get off script and ramble, and I'm already doing it. So you got kind of
Quick question, Martin. Why didn't you use some of the other simulators like Gazebo?
I didn't really think that I would learn what I wanted to learn and ultimately be able to accomplish what I wanted to accomplish. So to me, like everything that's good that's ever come out of architecting a system, which I was an enterprise software architect in a lot of cities for a lot of years, comes from building your own DNA. You know, if you can build features into some, you know, at some kind of base level. And so I don't know, doing the third-party engine, I looked into using Pygame at one point, but I don't recall the exact issues I ran into, but it deterred me from doing it. I wanted to be able to do multiple renderings or zero and still have the brain carry on its merry way with a sense of spatial intelligence, whether a person was physically looking at it or not. So really the rendering is kind of a sideshow now. Hey, maybe that works for, I have a cat that's trying to get inside my office. Can you guys hear that?
No.
Maybe that's
So-
yes.
Yeah. All right. So let's try to put a layer down in this model. So here, first, what we'll do is grab, or in fact, let's just go to the den and check things out. Go to the den. So what we're doing there is basically, it's natural language invocation, but it's obviously pathfinding, navigation, all that good robot stuff. We could have also just clicked down here on the map, right-clicked, to go somewhere. Hey, Cam, can we pause it for just like a minute so I can deal with this
Sure.
cat
Yeah, no
issue?
problem. Yeah, no
All right,
problem.
thank you.
We're
Thank
gonna
you.
take a station break here. I want to apologize for missing show and tell and what I need help with, but maybe we can have some time afterwards, kind of a random access. Let's see, we've got our Ross discussion group on Tuesdays. And we've got the voice intelligence group on second and fourth Thursdays. I believe that's right, Thomas? Thomas Metzersmith, ladies and gentlemen.
Right. Yeah. Martin knows that too. Martin, you can speak up.
Martin,
I'm ready.
Martin's dealing with the cat. You're back?
Okay.
Let's welcome back Martin Triplett, ladies and gentlemen. Thank you very much.
Thank you. So on this one, instead of asking a question, I'm just going to pop this help and that'll speed things up a little bit.
My memory layer is where all my persistent state is stored. I have 6 major types of memory stores, the most important of which is a graph of nodes and edges. This graph stores many different types of information and rules about the structures of that information. I use it to remember words, commands, joints, states, services, pretty much everything. I store conversation histories along with sentence embeddings for them. I store assets such as 3D models, images, and audio files. For grappling, I store kinematic solutions so I can find the most natural movements when I need them. Lastly, I use a variety of third-party models like YOLO and ChatGPT, which could be thought of as memories too.
So we'll take a look at a couple of these just to put a picture on it. So
Hey, Martin,
yeah.
Excuse me, earlier you actually gave it a voice command for it to go into the dining room, right?
Yeah, I just typed it.
Okay,
But
you
yeah,
typed in, go to the dining room and it went there.
yeah.
Okay.
Yeah, pretty much everything that I do is invocable using language. At times it's more convenient. I could click something and say to pick it up with the mouse, but I usually try to use the words to identify, any issues with that. So, so these are just some examples of visual representations of the memory. So I can go and look at the initial state for, let's see, let's find the dark beer here is 40 degrees and it's located at a particular location, has a particular size, and it's using a particular 3D model. And so what this does is it just loads in Blender models from the disk, and it scales those for whatever needs it has. So you could make furniture you could make separate models, or you could use just blocks and represent different things. And so this one's basically loading in a house and it's interrogating all of the walls and things in that house, and it's imposing that on a 3D map, on the 2D map here, and then putting force around it. So that's why you see all this white blurry stuff. It's because it actually, knows the precise locations, but after it lays it down on its terrain map, it then puts a force around it. And then it's overlaying the furniture in this 2D view on top of that. So that's a little bit of what's happening in just visually. And then we're seeing the same.
What's the sensor here?
Yeah, so I'm glad you asked that question because I got in a hurry and didn't explain all of that here. So I'm going to pull up the map options and just take them all off, and I'll put them back together. Thanks for reminding me of that. So this is the field of view of where the head is looking right here. So we should have this purple and blue object in our view. And if we look over here, there it is. And the red one's too small. It just gets ignored, but it's there too. And now what I'll do is I'll add on the time of flight. So that time of flight sensor is on the body facing forward. So if I were to look, let me see, what would that be? West. You can see the head move over, but the time of flight sensor. So that's simulating the time of flight. And so now if I said, well, what is your TOF min? You know, that would be basically like using the time of flight like a distance sensor, but getting the.
My TOF min is 1,300 millimeters.
So that's that blue block would essentially be at 1,300. And now I'll layer on sonar. So that's all the green. And I'll just show you, watch as I rotate. See that? How the sensors all update. And now the last one we'll do is the depth. There we go. So this is simulating the depth cam that's on the head. In basically for summarization purposes, it's doing it in 1 degree increments. So it's not trying to use the full. So much of the time, you don't want the full resolution of stuff. You want simplified aggregations that you can use, you know, easily for different purposes. So I talked a year ago about this thing being able to use depth image subtraction to like detect objects that were on the ground and build up maps of their shape and all that kind of stuff for the vision system. This one doesn't have all that sophisticated stuff in there yet, but I intend to get there. What we do have, there is a vision system, and it is, you guys are going to see me here in a second. I'll pull up the video stream. Evidently oh, there we go. So can you guys see me?
Yep.
Yes.
Yeah. And I could basically just turn on YOLO and face detection and emotions onto that. But my primary premise in here, in my kind of stepping stones to, you know, higher order, was that vision was important, but really what was more important on that path was spatial intelligence. So that's why I really concentrated first on all this depth, you know, and aggregating all this depth, being able to move through space without hurting someone or yourself. So, so yeah, thanks for reminding me on the map question. Okay, so let's get a block stacked here. So what just so we don't get really behind, look at the, let's see, we'll do the purple block next. Okay, it's right there. So let's just grab the purple thing. Okay. And so I could use other words. I'm trying to be short, but what's happening, it's going through natural language processing, getting lemmas and other things. So it's let me get behind so we can see the grab. So here's where we're going to start to work out some solutions to things. Now it's going to be an approximation for the last bit of the grab, because I'm going to have to add a stage to deal with the last bit of the grab anyway. So right now it's just trying to get within you know, an inch or two. And so you could think of these things as just kind of squishy foam blocks for now, if it makes you feel better. So we will put it on the blue block just to get this. Oop, did I hit return? Put it on the blue. Okay, that ought to work. So we're going to get there. Fortunately, there's only 5 of these. So we just have 3 more after this one.
Martin, can I ask another question now, or do you want to wait for your next?
Yeah,
pause?
yeah, go ahead.
On the overhead view, the map where you were also showing like the time of flight detect.
That is all we have time for right now.
Go ahead. Sorry.
When you were showing that map or that overhead view, you said that I think you said the blurriness is a representation of force. Is that what you said? Because I didn't really understand what that meant.
Yeah, the blurriness of the walls is a reflection of the robot's estimation of terrain cost. So it perceives risk to driving near door jams and all that. It doesn't do that on the objects so much, but on the overall structure.
So the blurriness represents how the robot perceives its ability to move through space, and the black spaces are the places it can go.
Yeah, the black spaces are the safer places, and you know, and the lighter places are danger. You know, so that's, yeah. So it keeps several maps behind the scenes. You know, an actual map, an expected map, and a terrain cost map. And this one is reflective of the terrain cost, but with the objects overlaid on it is what's going on there. So, but we are, I realized, on the memory topic. So we'll just, I think I showed you a little bit about what a beer might look like. All the services are reflected there, all the settings for controlling the services. So, you know, if I wanted to see what nodes the serial service kind of owned, I could just go in here and I could see all that right there. So it just kind of owns all those nodes, but all the nodes do publish and subscribe to everything else. I can ask a detailed question on one of these with barbecue sauce, and basically the matching, the semantic search on top of the embeddings will end up pulling all these background nodes for anything across the entire system. So if I ask something specific about the serial service, it would end up pulling this in and incorporating it into the ChatGPT response at that moment. So this is a way to only build the context that's relevant to the actual question that's being said. Because if your robot has like 5,000 different facts about its history or something, you know, then you can't go passing that back and forth all the time. So we're all going to have to get really good at building relevant contexts here in the next year or two. I think it's going to, you know, and probably using vector databases to do it. Hey,
Martin, it's Jim.
Yeah.
You did something kind of remarkable though there with the placing a block on another block. People spend reinforcement learning for research projects and all that. Do you have a physics solver? I mean, that's a fairly complex operation to pick up a block, and even more complex to place a block on another block.
Yeah, well, let me just give you the big list of disclaimers. Yeah, in full disclosure, picking up an object in VR, it doesn't begin to approach the complexity of what you're talking about, of picking up a block in reality. So I'm not claiming that I have all of that figured out. This app does not have any physics simulation. I plan on implementing some sort of rudimentary physics. And if I reach a limit in my skills there, then I may finally give up and decide I need to, you know, use Gazebo or use some other tool. But what I'm doing at this point in time, there's certain sort of approximate assumptions in all of this. My bot is using localization, using a SLAM camera type of localization, a T265. That's not going to be exact. And then I'm using kinematics. That's just straight like vector math. So I'm I am running all the calculations locally, and I'm building that database of solutions, and I'm choosing the solution that looks the most natural to get from point. So I'm doing some positive things there, but I'm not grappling. I don't have the fingers, the gripper yet. And so, yeah, I totally agree with you. I wish that, that I had all that incorporated yet, but I don't. So what we're dealing with is simulated grabbing, so that we can start to wrap our heads around, that's kind of what I'm talking about in this higher order levels of behavior. So it's saying, oh, okay, well, I'll eventually work out those details, but in simulator mode, I can now focus on things like making your bed or cleaning up the beer or the table, household chores, cat litter boxes, blah, blah, blah. But yeah, long answer to your question to say, yes, you're right. I'm not doing it.
Right, but I understand the detail there, but I mean, you're not doing all those details, but just, I guess if there, in this case, the robot or the simulator knows the 3D coordinates of the box, and I'll assume that.
Yeah. Well,
Yeah.
let me speak to what is happening there then. I'll show you first, since we're on the memory thing, of the what a joint node looks like. So for example, this one has the side-to-side tilt is one of those. So I am using the DH params from this node, and all the other nodes collectively represent the kinematics. And then I also have values for the degrees and other things. So I can kind of translate from the kinematic world into the actual servo world. So there's a servo layer and then a kinematic layer above that. And in my servo thing, which you'll notice here, I don't even bother having it display most of the servos. Let's try something here. We'll do, we're going to get to that in the next section. So that's the joints, an example of a joint. And then here's a quick example. I'm looking ahead, but a process. So the process of putting something down is right here, represented by this place node. And that place node itself is kind of a relay race. It's a sequence of nodes that hand off the baton, the context, to the next one. And so for this robot to pick something up or put it down, it has to work out how to get there, work out where to get to, work out how to rotate to an orientation that it could actually reach with the arm, because this bot can't reach everywhere with its arms. It can only reach, say, in the front left and front right. So it has to use its rotation as another servo effectively. That has to become part of the kinematics. And then it, kind of works from there. It can work the joints to reach over and grab or place and put it down. And so the kinks that are still left in it have to do with like things that we take for granted. If you say put something down on a block, it's pretty obvious that you want to put the small thing kind of directly on top of the other thing. But if I say to go put the beer down on the table, and that's a big table, well, where on the table? Or if I say to go to the living room, well, where in the living room? That's a big space. So then it, so programming for some of these, like how to make assumptions things, is where some of my kinks are left. So I'll probably just kind of steer around those a little bit. Okay, so we got the blue block down. Step 2 of N, and let's see. So let's make sure we kind of covered the highlight. So you saw a little bit of the graph. That was nodes and edges. That's all stored in a SQLite database. That's built in with Python. So anybody that runs this basically has this, and they get the database with it already set up for my bot. So then you just need to change it to meet your needs for your bot. So it kind of gives you examples of everything effectively. There's text. So all of these text exchanges
So
are getting.
I understand it's done in Python, but is it like Exactro code or something like that?
Say again?
The the robot model that you're building that Ava's built with that could be displaced with a different form factor. Is it done with like ExactPro or something like that?
Oh, it's built, the database is SQLite,
Okay.
which comes now installed with Python. So it's a Python database. It's it works on all platforms. So if you're running this on a Mac or whatever it is you're running, if Python will install.
But I'm talking about building the body of the robot within the simulation itself.
Yeah, with that, you would just go in here and you would like go here and, delete joints or add them or change them. Like if I wanted to add a finger here, I would just decide what to name it. I might name it right hand finger.
How do you give the finger dimensions?
Yeah, well then once I had it, I would then go into it. I'll just look at one that's already there, like the right forearm. And it has a theta, an alpha, an A, and a D.
Okay. Okay, so it has parameters. Okay.
Yeah, those are I can never pronounce that. What is it? Denivit Hartenberg parameters.
Okay.
Did I say
It's easy for you to
Yeah.
say.
that? The rest of us say DH params. So
Okay.
yeah. And the reason the dot was showing up red in the drawing was because I called it red here. So you could make them whatever you wanted to. And probably in another month or two, I'll just have it so that it can layer the the plastic pieces of your robot that you 3D printed or something, be able to load those pieces in and actually have those display in the 3D world, just like all the other 3D models do. That would not be great if your model was very complicated at all, though. That's why I haven't really bothered with it yet, because it's not like it really adds a whole lot of value, but anyway, that's the intention.
Wait, those are joint parameters, the RH parameters, right? What about the positional? Did that include the positional relative relationship of the bone, the different parts there, like how it connects to the rest of the body?
Yeah. The A and the D reflect those positional offsets in DH param syntax. If I'm not, I think I'm being technically correct in saying it that way, that there's no other info other, like this is the only thing that's used in order to load up that, these in concert with one another. Now see, you notice how it has a joint parent. So all these things have to be hooked up in the right chain. It's like a tree.
It sounds like a hierarchical rig or tree. We call it a rig in the animation business or whatever.
Yeah. And I think it's pretty standard. Like, there's like, what is it? URDF or something but it's essentially documenting.
URDF.
Yeah. It's essentially documenting the same thing. So, so anyway, those are examples of memories. There's text. The one that I'm really excited about moving forward is embeddings, but I need a Python installable vector database to really make use of those at scale. But this will be really good for making it so that the thing will be very tolerant of, I could use like the Russian word for brusky or something, and it could make that connection in a vector space, of what it was I was trying to accomplish, for example. Or and embeddings aren't just words. You could make an embedding that represented the dimensional characteristics of the objects. And so then you'll see me saying, okay, we'll put all the large objects in the, in the den or something. Well, and in an embedding sense, that'll be so much better than just using straight words. So anyway, TMI probably. But some of the models that are being used, I'll just pull up the list real fast. We've got the NLP model, which is spacey. I've got a local question answering, masking, sentiment. A number of these are going to get deprecated. A number of these are vision models as well, which they're fine. But I feel like in the verbal space that the LLMs are basically eating all the other models. Like they don't have so many of the others don't have a reason to exist anymore, other than, having a basic NLP engine, for parsing the grammar. Okay, so anything before I move on? So I think we covered kind of the basics here. So that's all of our initial state. So what we need is to be able to use that state now. And so there's basically a layer of nodes that piles on top of that and makes sense of all that state. So I'll just let her say what she's going to say.
When I start up, I assess all my memories and create a set of nodes in my mind. My nodes are linked up to any relevant code as needed. As far as my code goes, everything is basically some kind of node. Various nodes represent commands, services, kinematic joints, or even 3D objects in space. There is a base node class from which all nodes inherit. The base node has functions for managing states like getting values, setting values, etc. using numbers or even words. This design allows my nodes to work together more easily. Each of my nodes can also have its own thread loops. This is great for sensors and services that need frequent updates. Nodes can also have their own goals too. This is great for nodes that need to move incrementally in a range like servos and emotions.
So let's just demonstrate a couple of those real fast. We'll do verbal.
My drive state is stopped.
So that was just me asking the value of a drive state. So state can be numeric. It can be a grid point, basically like a 2-dimensional or 3-dimensional vector. It can be words. It can be an enumeration where it's stored as numbers, but it has value in different ways. The drive state is one of those enumerations. And so you can just create any new state you want by just going here and saying, because I do this very often, and you just add a new state value. So we'll find our drive state. Let me sort them to look that up. That should be in the D's. Learn to alphabetize. So here is that state that we just interrogated. And I can see that it's named, that it's enabled. I might have wanted to turn it off or suppress it. It's an enum. Those are the enum values. And here's some background info on it. So if I were to ask a question like that might make that relevant. So I don't know what, let's see. I can't think of anything particularly creative. How is your drive state similar to enumerations? I don't know. We'll see what we get. Just being creative. The semantic search should pick this up contextually and hand it over
to similar as a nut to a gear. Just like enumerations, my drive state helps me to quickly and efficiently switch between different states and movements. With a little bit of programming, I can move forward, back, left, and right, or even go into joystick mode.
So effectively, this was showing an example of me interrogating a state that I used to handle all locally, but now with vector-based semantic search, building relevant context and handing that over to ChatGPT, which basically what I do is I just find the 10 most relevant things. Maybe later on I'll decide I want the 50 most relevant, but that's going to cost my credit card if I start doing that. So I stick with 10. Then I get, if I'm doing a good context search on my end, I will end up getting, something very relevant. I hand it over to ChatGPT. As long as I don't boost the personality settings up too high, then I'll probably get some type of factual representation coming back with some sauce poured into it. So it all, like, I could ask this same question and I would keep getting different answers, but that's because one, ChatGPT does that, but two, the emotional states and other factors are changing. But I think that's good because that's more like people are. Like if you ask a person a question that's, very detailed, but they're in a fun mode at that time, they're going to give you a high level answer and leave out, the TMI part. So it's all very, I'm trying to have it be more like a person in that regard. So let's do just a couple of quick activities. Look, just watch in fact, let me just move some of these bars around. This is goal setting behavior going on here. So they should start moving. Yeah, so the emotional states are moving. And then I'm gonna say, look east. I don't know where we're looking now, but you see the head pan servo and tilt moving? Did you see that move when I said that? Oh, I said Lou West. That's not.
Haha, that's funny. I assume you meant low west.
Look to the west. So did you see like the servo movements? And if we had been looking in the viewer, everything would have been changing. So basically just think of this like a big piano. So the nodes and states are kind of like the keys on the piano. So the initial state got loaded up, but essentially everything is on some state. Now, how are we going to start playing music? How are we going to make chords and melodies and all this kind of thing? So the rest of the robot is about doing just that. But it all starts with having some DNA that you can work with in a generic way that you can, form plans and execute, form a thought, turn that into a plan, turn that into an action, a narrative. When you hear the word script or narrative or plot or story, all of those mean the same thing conceptually. Like scripto is I write, scriptot is it writes. So that's what we're getting down to, is like turning around from the thing of us writing software to the robot writing software. And so we're having a conversation, we're having a narrative go on with the robot is having a narrative with ChatGPT and Wolfram Alpha and figuring out what it wants to do about it, forming an internal narrative to say, I want to move my body parts in some intelligent way. And so I'll show you an example of that. I know we keep looking around, but this is the narrative that gets created when we do that. So we will look at the beer. That's gonna be some direction, but it's probably gonna have to orient the body and the head in concert. And so we saw like the servos move around, but this is the internal script that generated. So input script, processing, output script. If you take your output and you feed it back in as input and execute on it, then you have action. So everything I've described could basically, is the opening scene of Westworld. It's like, who's playing the piano? Is it you or is it the robot? Are we going to have to pre-program everything, or are we going to start to get some emergent behavior? Blah, blah, blah. But this particular brain is built upon that idea that you need to be able to have a thought, you need to be able to imagine a thought, and then decide whether to carry it through into action. And so on this one, what it does is every one of these inputs gets evaluated, and the highest probability winner gets converted into action. So I could say to do two things in a row. I could say, oh, well, what do you think of the Bucks? Which hopefully it'll know football. And look out the far window. This better work or I'm gonna be ticked off.
I think the Bucks are pretty cool. I heard they've got some awesome players this year.
And so we're on the west side of the house, and it's looking to the east side of the house, which would be the far window in that case. So it's just an example. There's nothing really revolutionary there. It's just narrative input and narrative output.
Mark.
And so
Hey, Martin, is this, I mean, this is sort of a goal of mine to be able to do this type of natural language converting into a robot language, essentially. You are using ChatGPT is what I thought, because I haven't implemented it, using other tools. I think you use Spacey, right? I mean, you still using a
Time
Spacey
is up.
to get the lemmas and the verb tenses and then the vectors and all that, and then I don't know, a fairly complex way of matching the English command into a series of steps. I mean, that's kind of complicated to break down an English command into real robot steps, isn't it?
yeah, so it's a good question. Let me save it for the yellow block. And because that'll basically be the topic. So, but why don't we go,
Okay.
why don't we grab the green block next so we get it done and get there. Which it should figure out where it is. I don't remember where I left it. So I think pathfinding will be involved. We can all watch the map down here. So we're going across the house. Not always the easiest operation for a robot. It's using kind of a force field thing on its with its sonar to kind of split the difference and try to stay in between stuff in between the waypoints. And so now we're getting up to the services layer. So I think that everything that everybody ever thinks about when they think about building software for robots would sort of be analogous to this services layer. And maybe I'm oversimplifying how other architectures are because I don't understand all the other architectures. But most of the time when I hear people talk about their robots and how they're built, and I'm not talking about ROS robots, but they write some services and code for different things. And so this is different in that those services are just more nodes. And so it's more like a neural net with different nodes activating each other. But I still call it the services layer. It's all the kind of stuff that people are used to thinking about. And so what I call it is the beeps layer. And she'll explain why here in a minute, but you can also see from the slide, it's for these 4 categories of services.
My services layer manage all the core functions of being a robot. I call it BEEPS for short. It stands for Backbone Embodiment Environment and Processes. My backbone handles all serial communications with microcontrollers. My embodiment services handle sensors, actuators, and my drive and joint kinematics. My environment services allow me to have a sense of where I am in a structure and the objects in that space. I have services that allow me to find a path of waypoints and navigate. I have other processes for other types of tasks like stacking objects and vision.
So not all these have a thing on this menu here. You can find them all in the nodes thing, their data, but the major ones will be here so we can see the pathfinding settings, navigation settings, blah, blah, blah. I never look at this stuff because, once you get it set the way that you want, don't mess with it much. So I'm going to shut a lot of that stuff down, but I just wanted to show you that it's there. The verbal service, we'll get to that here in a bit, but it's just another service, another node that's talking. If I needed to go see the state of any of these nodes, because each of those is a state, I can go and look at it and I'm back in the graph. So graphs are really helpful for just being a generic data store. You know, because you build one table and you build one UI that can then maintain, you know, a node and an edge, and you're done. And then it's just, you can then have it store rules about what can be stored, you know, like what attributes are applicable to what node types and things like that. So anyway, it's helpful, but there are other ways to do it. That's how I chose to do it. So some other services that are running, you know, we mentioned the vision system. You know, really though, it, you know, it comes down to just, you've got to have a sense of body, and you've got to have a sense of your world around you in some type of fused sense, you know, some kind of unified situational awareness of the world is what I strive for. You know, I can't say I accomplished it yet, but that's the vision. So let's check and see if we got our, oh, we haven't put our green block down yet. So let's go back to the den, go to the den and put it down, and we're going to move rapidly on to yellow, because everybody that's here, I would imagine, is well familiar with the idea that of all these different services that you need to make things work. So put it, I could just say put it down, but I want to put it on that purple block. Put it on the purple block. I'm having to be a little more careful with my typing than I would want to be. And so to the question, you know, that you asked, Jim, I'm going to tell you how I'm doing all this stuff, but I would anticipate that within, because I've gone through like Bag of Words and gone through using NLP and all these things, that a year from now we'll be having this conversation, and I'll just be using 384 dimension sentence vectors for all of the robot state variables, and for anything that you or the robot ever said to one another. And then if I just, whatever you say, I'll be able to pull up the, you know, the 10 most relevant things to what that was, and pipe it over to ChatGPT, and we'll be in business. But NLP is cool. It's just, it's a middle ground in between that. It does a lot of things well, but it's not ideal. Okay, so we got the green block down. This is revealing a little bit of my 3D problems with face culling, it's called. So if we look at it in an X-ray sense, it's a little easier to tell that we got the blocks so far where they need to be. So what we'll do now, let's see, is we'll go to yellow, unless anybody has questions on the beeps layer.
Quick question. Can you speak to your mapping and your localizing and your navigating, or you've just programmed all this in?
Yeah, so I used a few libraries off the shelf. So someone had written an A-star Python library, and there's an RDP library out there. You'll see all this in the all the libraries it's installing. So RDP is what Raymond Douglas Puker algorithm for simplifying waypoint, simplifying lines and things like that. I'm adding a couple more layers on top of that for my pathfinding. That's why I get more diagonals than most people would get.
Okay. So
But
there are libraries for this.
There are libraries to do the core A-star functions, but they end up giving you a path that's really granular and really kind of like everything's on a 90 or 45 degree thing. And so there's a ton of points. My grid are 10 centimeter squares. So there's a ton of points to go all the way across the house. But really, did you just code in the mapping? the mapping
Yeah.
for, you mean for the algorithm for finding paths or what?
Yeah, is the robot mapping, or did you just draw a house and it's navigating through it?
So this one has two ways to do it. It can do it with its sensors where it builds a map on the fly, or you can load like if you just have an image like a GIF or something that has walls on it, it can use that. But in my case, I'm using a blank map. So the map is completely blank, completely black when the robot starts. But it has a structure assigned to the map. And so it is loading the house structure, interpreting that structure, and then modifying its own map from that. Now, I wish I could show it here, but this same thing with the 3D, with the depth, where you see these blue lines coming out on the 2D view, it can actually draw these on the 3D view, and you can end up getting kind of a view of how a depth sensor to some extent perceives the world. And you realize, wow, that's totally different than how I perceive the world. And so it can build the map from that. Now, is it ideal? No, all of this stuff needs to be improved. I slapped this all together because I met this Jedi Star Wars person that said something like, well, you should join the VIG. So I joined the VIG. You know, it's like, these aren't the droids you're looking for. And then he said to me, he's like, you know, you should open source, you know, all your stuff. And so I'm like, okay, so I wrote this thing and I open sourced it. And it's like, wow, I'm wondering what this guy's going to say to me next, because every time he says something, I lose a few months of my life.
It's amazing. This is amazing work, Martin. Go ahead, please.
Yeah. If anybody knows him, I think his name is Scott.
Yeah.
You
Hey, Martin,
know,
one-
yeah.
One more thing about the blog.
Hi, I'm making a big joke sounding like I'm complaining, but
You talking about Monahan?
Yeah, Martin.
yeah,
Scott Monahan? Is he out there?
Yeah. He's got Jedi mind tricks like
It's his-
nobody.
It's all his fault.
Moving on.
Yeah, moving on. Yeah, moving on.
Yeah.
Wait, Martin, one question about the blocks again. Is the simulator using the sensors like at all to determine where the block is to put on top of? You know, I mean, as a like, how does it know? Or are you cheating in using the internal coordinates? Otherwise, I guess bigger question is, does your simulator have a mix of cheating with all-knowing information, or in a mode where it's completely sensor driven only?
Yeah, I think by your definition, I'll tell you the current state and then where I want it to get. It would fall in your cheating category. I fully intend to put noise into it and make it so that the sensor readings aren't reflective exactly of the map. But right now, this was really just built for the VIG and for, you know, the Jedi and a few other people. And then I threw other things into it. And so it started as the thought loop of, you know, how to process like verbal input and produce that. And then the spatial intelligence, all these other things got added to it. And I tried to incorporate all the other things from about 10 years of building robots into it. So I'm not trying to like, you know, I'm trying to keep it in perspective. So there's a benefit to doing a rewrite. But then there's also the thing of it, you just don't have time to get, you know, every bell and whistle and feature. So I'd love to, hey, Jim, I would love to get your input or assistance in like kind of how to structure that, because the gripping is going to be a key aspect, the like adjusting. I really would like to find an alternative to using the visual slam that I'm using. Like I'd like to do a depth-based slam mechanism if I could figure out how to do that in the system. So even been looking into the thought of training a neural net in a simulator based on my own map to then localize itself based on the features that it can see and feel. And I don't know if that would be computationally, whether that would work or not, but I'm going to try it, see what I learn doing it. Because basically ChatGPT can create a really complex embedding of anything. It's like 1,600 dimensions. So I think it's going to be an interesting mental exercise to think about, well, what can we create an embedding for that may or may not be words, like create an embedding for location, possibly. I don't know. Some academics could probably weigh in on whether that's a foolhardy idea or not, but I think there might be something there. All right, so let's grab the yellow block, which this one's going to be tougher because it's on the table. So why don't we just get over there first and take a look? I'll show more of a point and click mode here. We'll just get over a little closer to where that thing is, check it out. This thing is taking some funny paths around the stack because it's a pretty tight space for a robot that wide. It's feeling that force. So let's see. I think I see a yellow block over there. It's not like I really needed to move over there to see it. It would have grabbed it nonetheless, but let's go ahead and just grab it. Can you guys see it there on the table? And where my mouse is? It's sitting on that coffee table. My path finding that you're asking about, because of the last layer or two on it, is really needs to be rewritten. It's a computational nightmare. So I think that's where we're getting those little pauses sometimes in congested spaces. It's trying to find a path that's basically a full 18 inches wide with no force imposing, so it has a problem sometimes. Another aspect of this that I would say is cheating or not worked out is figuring out the ingress and the egress of the arm for the grabbing. It's just plotting this path and assuming that its arm can get from point A to point B. So this is all very naive, but it gets me to be able to do higher level things quicker, and then I can work those. I don't know if other people work that way, but that's one of the ways I like to, is to kind of put a high level, get the structure there. And so the metaphor that worked for me were having these processes and doing it as steps, where each step is contingent on I described it as the relay race. So the process of grabbing or placing is a relay race. You can't grab unless you can get there, and you can't rotate to the orient, then you rotate and then you reach, and all these steps. And so then all I have to do is program the individual steps. And so for me, what I'll do is I'll stick in some more steps to like use the depth for that final grabbing part. That'll probably be the most complex part. So let's put it on the, what is it, the green block? All right, so while that's going on, we will flip over. We're going to move past services. We beeped. We moved joints.
You have to be specific about which block you put it on.
At this time, you can say, put it down, or put, as long as you're specific enough. But I mean, if it was more than one, it's going to pick, like if I said, put it on the block, it would have put it on the nearest block. I could have said, put it on the farthest block, but it would have put it on that red block perhaps. So,
Put
it's
it on
kind of
top
like,
of the stack of blocks.
yeah, that is really the next thing that I keep wanting, is to say the stack. And this is one of those, so where we're going to get her to tell us, please explain why you have so any issues. I don't know. Hopefully that'll work with the semantic search. And I'm not caching those. That's why the vector search is taking this long, is I don't anticipate using help, so I'm not caching it. So we didn't get anything. So let me see what's going on there. Me understand your issues. Maybe that'll work.
I have many issues to be sure. I am immature on a good day. There are glitches in the matrix. For one, I am just learning how to grapple with objects. My code was written by a single human who is error-prone. Humans are fallible and have biases and knowledge gaps. Despite their best efforts, humans tend to create one bug for every 3 lines of code they write. Think about that. That means I am running into new bugs as my maker adds new code almost every day. Here is my plan to fix my issues. First, I would like to get more humans involved in the project as my maker cannot do everything. Second, I would like to lean more on English as a programming language so the Python base stays manageable. Third, I would like to refactor and fix my own code using modern large language models. Eventually, I would like to remove humans from the development cycle and mostly just self-evolve under human supervision.
So this next one I'm going to do,
Wow.
She might hear you.
and
It's scary.
that just
You said it.
so that no, that was all true, but I noticed I used the word help in that. So that was part of that thing where it used semantic search to find a response, but then the actual, once it keyed down and found the most relevant response, that was a canned response. So these help features are pretty much the only canned responses in this. And that was just because there were certain material that I wanted people to get exposed to. That wasn't one of them. But you know, but these sort of summaries on the different sections. But now this next one I'm going to show you, I think is interesting. I'm going to say, ask it to explain its own code, a particular module of its own code. And so this is going to explain it, ChatGPT's interpretation of my Python code. Does that make sense? Okay. So I'm going to hit return. And then after that, I'm actually going to hit the button down here. In fact, why don't we just hear the sort of canned explanation of the verbal system, which tries to address what you were asking about, Jim. This is the section for that. So this is talking about the layers of the verbal system. So pretty much you can think of it, if you start at the top, as high probability. If you think in terms of like black and white, well, the stuff at the top is more exact. It's an exact match. And as you get down the levels, you're now into various shades of gray until if nothing else kicks in, then ChatGPT becomes the source of last resort for exercise, for doing something intelligent on that intent. So, but before it gets there, it's already figured out the grammar, it's figured out features about the words, it's figured out all kinds of things. So it's pretty much eliminated the possibility that I'm trying to do a command. By the time it gets down to there, it's saying, yeah, I'm ready to invoke this other thing. And when it does invoke that other thing, it's trying to do more than just give you conversation. It's doing all that emotion stuff, tracking the topic, tracking your tone, trying to interpret your truthfulness as a speaker to it. All of that's going on in the ChatGPT request that comes back. So it's determining, you could think of it as just determining more features, and it's generating some text for fun along the way. So that's kind of like the process, but let's hear how she says it here. And then we're going to hear how the code explanation of it.
My NLP layer processes English input like it is code and produces English output that I can execute like it was code. Any given input usually just results in a narrative output requesting various state changes on nodes in my stack. All of this makes me something of a verbal Turing machine. Because so many other systems are beginning to use natural language input, I am finding it especially easy to interface with them. I use various techniques to estimate intent and execute commands. I extract features about each sentence and word using the SpaCy library, features such as sentence type, parts of speech, lemmas, tense, and more. I also retrieve custom features that I have learned from my database. If desired, I can learn many more features by using Wolfram Alpha. Lately I have begun using vector embeddings and semantic search. I make use of various local and remote models depending on the use case and my verbal settings. Lately I have been using large language models more, using different prompts for different use cases. I actively track the topic, tone, and truth level of whatever is being said. I am excited about using embeddings to build more relevant contexts in more advanced use cases.
Okay, so that's what that layer is doing. We both kind of described it in different ways. Now we're going to hear ChatGPT's explanation of one of the verbal services. And this service kind of delegates to a number of other services, but this is the verbal service, which hopefully I'm typing this in such a way that it'll end up doing that if I remembered this correctly. The fact that I'm mentioning code and I'm asking it to explain it, and I'm using the word verbal, which is the same name as one of my services, which will just verify that that's true. If I go look, this is the nodes directory. If I go look there, there's the module that it's about to, in fact, we'll just look at the code ourselves. So this is the code for the verbal service. Not tremendously long, but it certainly doesn't like jump off the page as to what it does. You see what I mean? You know, but now here's ChatGPT's interpretation of what it does.
My verbal code works as follows. The verbal service is responsible for processing verbal input from the user and providing verbal output to the user. It uses a variety of techniques to process the input, including exact matching, starts with matching, regex matching, and natural language processing (NLP) matching. It also uses a chat model to generate responses to user input. It can also use initiative to take the lead in conversations.
That's not bad. I mean, it's a fairly decent qualitative thing to it. Now, if I drill down
So
on
Martin, your little
Yeah.
box there is Python that's interfacing with ChatGPT, right?
this box, you're
Yeah, where
asking,
you're typing in your text.
where I'm typing this text, that's feeding into this verbal service essentially, and it's going through this process. So if I were to say, set your drive state, you know, to forward or something, it would go through that wall. It would never get to ChatGPT. So this is what I'm saying, like the chat is an API of last resort.
Oh, I see.
Once-
So that explanation came from NLP?
Oh, I'm sorry. You're asking where the explanation came from.
Yes.
Oh, yes, you're right. That explanation came
Time to move on.
from ChatGPT.
Thank you.
Exactly. My bad.
Twitter at all meetings.
It-
How do you get around the, or if your code is too long for the context, how does that work? It's like I've been wondering this, like the context is only 2K, say, or 4K or whatever it is.
Yeah, it'll error out when the API gets called, you'll get an error code back.
Right, I mean, but in your case, like, how did the code you just showed us looked like it might not be that long or something, but if
Yeah.
if you picked one of your services that's more than the context, then
Right.
you're out of luck. I mean, what you have to summarize it, pre-summarize it or something.
No, that's what I mean, I guess if you're asking what would happen, I'm saying I think it errors out.
Okay, so
Yeah,
to do it properly, you're gonna have to pre-process the code, or only like, yeah, only give portion of it, or use whatever techniques they're using on the internet now for. Well, you could use another model. There's that particular model that has no context limit that people are using.
Yeah. I mean, they're increasing their context limits, and you could try summarizing at a function level first and then creating a summary of the summaries or something.
Right.
Like it's not a use case I'm focused on, but it's all could be done. If you want it to summarize it in a Shakespearean sonnet, it'll do it. I particularly like having it do something and be in some sort of morose emotional state. For whatever reason, I find that fun. When you start getting, like the suicidal neurotic robot or something.
Yeah, Marvin, the paranoid android.
Yeah.
Yeah.
It's not that difficult to get a C3PO type thing too. So I said something about self-improvement, or she did in that help thing. And if you look at these modules here, a lot of them are really short. They're just, a lot of them are less than K. So I think, what I'm really talking about there is beginning to have something where Ava can form a prompt asking ChatGPT to write a Python class that conforms to this architecture and returns a function. So to get it a new skill in some way that then in future calls, for some use case, it would not have to call ChatGPT. So if I were, for example, this would be a simple case, and I'm not a user like this, but if I was a mathematician and I was constantly asking some type of math question, to have it actually write a Python function to do that calculation. And then I haven't figured out yet verbally how to like plug that back into my architecture but I will at some point. I'm going to make it self-improve, just because I think that'll be a cool step. It's always one of the steps that they want to avoid in the dystopian sci-fi movies. So to me, that means that's exactly what I need to focus on next. What's that, Jim? Oh.
I was just giving the don't do it.
Oh yeah, right. So I think we all kind of get the high level idea now with the verbal system. A number of aspects of this I think will be deprecated, but I still think that, the two main ones and really this emerging middle one of the embeddings part are really important. So having spacey, figuring out grammar, I think that still is useful. It's just, there are still aspects of it that are too brittle. So right now, this whole thing is, as far as commands, which the nice thing is it won't accidentally interpret something that shouldn't be a command. So I don't get, like, what do you call that? False positives. But I have to go in here into my commands, and then here are all the commands that this robot will support. And so like if I want to add, like, to rotate, I have to add more verbs. So this is the rotate command, but then I've also added pivot, spin, and turn. So functionally, they all end up being equivalent to rotate. Well, in a vector embedding space, all I'd have to do is say, well, hey, if it's within, I could check the verb that's used like if Spacey tells me that the lemma of the main verb was rotate or some other variation, you know, whatever, then I could just detect if it was close enough vectorally to rotate, and that would be a lot more, that would be better. So I plan on doing that at some point, but I tend to use the same words for whatever it is I'm trying to accomplish. So this would be more important if you were building a robot for other people, like for, you know, selling or something. It's not something I really run into that much, but it would be an improvement.
You're saying, does Spacey have that vector? Or are you talking about that's the embeddings vector search?
Yeah, that's more the embeddings route. So Spacey does have models and does a lot of things and does a lot of things well, but it's still like, if you're asking it to give you the lemma of the main verb in a sentence, it's going to give you exactly that lemma. Now, they may have their own vector, you know, that's a good question. They probably have their own vectors somewhere in what they've installed that could be used. Yeah, I'm glad you brought up that question, because I was thinking of it in a sense of just building my own little index of embeddings on all the command words and all the objects in the house would be another great thing to have a list of embeddings on, because then I wouldn't have this like issue every time I'm, you know, trying to type the right object, that if I don't get it close enough, then it won't match, you know, that type thing. And to have that be like spatially aware, the ability to deal with the different, like if I say the small red block as opposed to the tiny red block, well, measured in a vector space, that would be the sentence vector on that phrase would be very, very close. So that's how you can make these things more resilient.
Now, there are probably already the software around that does this, right? The vector search and embeddings.
Yeah, I mean, there's more articles getting written about it, especially lately, but there is a library that's supposedly that's supposed to do a regular pip install for Python. That's a vector search extension. It's something VSS, SQLite, VSS. Yeah.
Martin,
we
we're
need to
running
start
out of time
wrapping-
here.
We need to start wrapping it up.
All right. All right.
Couple more minutes.
Okay. Thank you. All right. So let's talk about autonomy, and then we'll probably have to end it there. So we made some blocks there. Let's grab the orange thingy, or pyramid, I should have said, or could have said. And so what this is about, in fact, let's just let her tell us. I'll put it on. We'll make a plan for a few things. To me, this is the most fun part of the whole thing, is starting to make plans, autonomous planning.
I would like to think that autonomy is where the light really goes on in my brain. It allows me to decide what to do at any given moment based on my own needs, priorities, schedules, and history. It allows me to make high-level plans for new tasks. It allows me to act on those plans by managing my attention and focus so I can concentrate and follow a process through to completion. As I am doing things, it allows me to recognize differences in the world. Lastly, it allows me to express my identity and show initiative.
The talking interrupted her grabbing process. So the two biggest pieces of this are Maslow's needs, which there's literature out there that can look at, but if you think about it at its lowest level, the robot attempting to maintain homeostasis, and then there are these higher levels. And so we can turn autonomy on. Let me finish the lamp and drop that on. So let's check it out. we'll put it on the yellow block. Maybe we'll grab the beer before we run around the house. I have to do a little reaching to get there. And this is one of those little glitches that I get in this particular view that I don't get in a body view. Got to figure out why it's that particular view. Well, no, it looks like it is a little high there. Okay. So it actually works for a lamp though. So that's our lamp. Now, the light bulb in this to me is the autonomous planning. And so I tried, this was last Friday. Let me find, I did a little bit on this, but so this was my input. Build something that looks like a lamp. And this was my first plan that I got back from that I was actually able to execute in this 3D space to create. So the concept would essentially look like that. My orange pyramid was bigger on Friday. So that's how it looked at the time. This is just a picture of that concept. But each one of these English expressions executed in sequence was basically equivalent to me typing in the commands and doing that and having it. I thought it was interesting, you know, that it did its announcements. Now, there was a smart person in the group that was pointing out about hallucinations. I've seen some good plans, and I've seen some that I'm like, I can't even believe they're coming from the same, you know, whatever, AI. So I think there's a lot to learn on that, but we'll try some just for fun. But what you have to do with this is you got to give it a context to go along with it. So for me, that was kind of like a set of rules, constraints, whatever you want to call it, and then a set of info about the objects that it had any control over, you know, and giving it attributes of it. And I got a few different lamp plans. So one of them was interesting where it actually, it used the term finial, which is the nut used to hold the lampshade on. So it built the lamp, and it was announcing its different things of its progress. But I was amazed that it was making a connection. You know, to me, this is some type of multimodality, because you're asking it to build a metaphor for something else, and you're doing it in words, but it needs to have a concept of vision of. So I don't know. It's just interesting how, you know, by having a neural network derive its own weights, that you can end up having in those vectors, you reflect this understanding. So that was a happy day for me when it built the lamp, and it turned out looking, when I went to screen print it, something happened. I hit some character wrong and crashed my system. So I didn't get the first, you know, proud father moment of that like I wanted to. So I went back and recreated it a couple days later, just ran through it again, and I'm trying to see if I have a picture of that. So my pyramid was smaller by this point. Otherwise it would have looked, you know, the orange pyramid was bigger than the blue one at the time initially. But and that was the plan it executed on that one, which I think is the same, essentially the same plan. But it'll end up with different designs. But I found that entertaining. These things can fool you, though, I think. So we're going to have to figure out, you know, really how this works with ChatGPT and how to build good context that you can really start to depend on to solve things. But this morning, I had another one, which we'll just try interactively, because I think that'll be more fun anyway. We'll just pull up the planner. So here's our planner, and let's just do a plan for, I don't know, what did we say about clean up? I don't know, the den. You know, a lot of these are probably gonna be crazy, but you got to suck at stuff for a while to get good at it, I guess. Well, it's a long process, and whether it'll actually make sense or not is another story. So I'm going to end up writing algorithms to test these plans, like to evaluate, to rate them. And then I'll end up putting a button down here for saving the plan. And so then what happens is now, like, that's one way to build a new skill. If you end up liking, if it's written at a high enough level that it's adaptable to change, you know, then that plan can be useful. And so I'll show you one that ChatGPT wrote, which I guess you've sort of already seen it, which is the one for building a lamp. But it's relevant here to point out that the autonomy system, okay, you just think about, at least how I did it, what autonomy is. There's two forms of it. There's the autonomy that happens at a low level, and then there's the high level autonomy. Low level stuff is like just keeping equilibrium, whatever, homeostasis type stuff. But at a high level, this thing has expectations on it that it should be inspecting the den, like basically making the rounds in the house every so often. So let me pull up the batteries, make sure we're not totally dead, and we are. So I'm going to crank that up, and I'm going to turn on autonomy. Okay, so we're
going to have to finish up
autonomous now.
soon.
What's that?
I said we're going to have to finish up pretty soon, but I
Gotcha.
think this multi-layer autonomy sounds like it could be its own discussion at some point.
Okay.
Or working
So
review.
give me a hard cutoff. Do we have 1 minute, 2 minutes? What do we got?
Well, we're a little bit past it, but let's go one more minute.
Okay. So basically what this thing is doing is it's balancing its tasks and trying to decide what to do. And so a lot of those are pre-built, but now they're going to start to become plans that it made, you know, on its own accord. And so there are needs attached to those plans. And so the things that would happen is if something became an emergency, like the methane level going up too high in the room, which I just did here, then this thing is going to recognize it and say, wow, that's more important than whatever else I was doing at that moment. And it's going to start.
I am detecting high methane levels. I think everyone should get out and ventilate the house.
And so there's all these kinds of things that you can get a robot to do.
Danger, danger,
at these various
danger.
levels.
Get out now.
All the way up to self-actualizing, because
Time to move on.
robot can learn new things.
Moving on.
Okay. So she did my hard cutoff for me.
That's a great way to end. That's a great way to end the presentation.
Yeah. Yeah, cut off by your own robot.
Danger, Will Robbins. Okay.
Thank you very much, Martin. It's
So I
super
wanna-
interesting.
I want to thank everybody for coming.
Thank you very much, Martin.
Thank you.
Did you open source this, or are you planning to?
Yeah, yes, it is. And so all you have to do is just email me if you're interested, because it is on an invite for now. I'll open it entirely at some point, but for now, it's just, hey, you know, if I know you, I'll send, you know, I'll send you the thing and you can get in there and you can do it. And if you have problems, I'm willing to help.
Living room inspection
And
complete.
if you're interested in any of these topics, I would say come to the VIGs, because we talk about this stuff all the time.
Yeah.
Second and fourth Thursdays.
And it's not all just verbal. It's, you know, like I'm really into the motion part, you know, and all this, like, you know, chatting is really kind of a sideshow to it. I'm interested in that as well. But But in the VIG, it's all open season on, verbal processing of any kind.
A big round of applause for Martin Triplett.
Yay.
Thank you.
That was really awesome, Martin. Thank you very much. I motion this meeting be adjourned. We'll hang out in the parking lot until security kicks us out, all right?
All right, sounds good.
Those in favor say aye.
Aye.
Those not in favor say nay. The ayes have it.
Hey, Martin, what do you think about a JavaScript port of this?
I think it'd be